Okay, so we're going to be doing workshop number 2, which has to do with the problems having to do with inequalities from homework task number 3. And these are even problems that have been worked out in each of the houses. So what I'm going to ask you guys is I'm going to call out a problem, and the corresponding house that has that problem, let's show the problem, share the screen, and show the solution to the problem, explain the procedure. I am going to validate that the procedure is correct. If we need to correct something or something isn't correct, then I'm going to walk us through it, okay? Please, when you share your screen, don't remove the screen sharing until I say so, and don't move the problem around the screen. So I can, if I do any sort of annotations using the annotate tool of Zoom, so it doesn't, so you guys can see and understand. So let's start off with problem number 28, please. I think that was that problem, problem 28. I think house algebras, you guys have that. Give me a moment to move over here. Okay, let's see, give me a moment to turn off the lights here. Okay, so we've got problem 28. So go ahead, house algebra. So give us a quick explanation of what you guys did there.
Yes, so based on what we did learning class, we decided to solve it by separating the equation, by doing half of the equation here and the other half over here. So when you separate them, it's really easy. Just move the x and the numbers, and we get the inequality, and the same with the other side. And at to get the answer, we just put them together again.
Good. Well done. Thank you, guys. Thank you, Arturo. Don't remove it from the screen. There's a few things that are important to note here in the solution that are important to note, because these are things that we always have to keep in mind or not forget. And I'm just going to mark them here. Let's use. The first is that the procedure that you guys followed is correct. You decided to separate the inequality into, let's say, part A and part B. And that is totally valid. So you separate it into two inequalities, you solve each of them, and then you just join them back, or the solution is going to be the combination or the union of these two. So that's perfect. Another thing that's important to note here, and I'm going to ask any member of Team Algebras. So you got to this part here, and then here you divided by -1. And what's the very important thing that we need to note that happened there when you did that?
So that the negative sign would disappear.
That is correct, Alfredo, but that's not the most important thing that we need to note of what you guys did in that step.
The sign should flip, no?
The sign flips. That's the very important thing. Correct. Correct. The sign flipped. And so this part here is very important for us to remember. When we multiply or divide by a negative number, the sign is going to flip. So in the first inequality, we had less than or equal. Once we divide by -1, the less than or equal switches or flips and turns into greater or equal. Okay, and that change stays until the end or until we do another operation. Same thing happens here on this side. You're dividing by -1. This division by -1 is going to be affecting the sign. And so we see that the sign flips. In the original, it was less than. When you divide by -1, it's going to turn into a greater than, and that persists to the end of this, or to the solution. The last thing is that once we join these two, we also have to be very congruent with the signs. So x is larger than -2, so this is correct. We have that here, and x is less than. Oh, we've got a very tiny, I'm going to say mistake, but let's say that it's an omission. Where's a very tiny mistake that we have there? In this, where it says answer here.
The equal.
Yeah, we have to remember and be very careful with that, you guys. We have to remember the original was less than or equal. You did reflect that in the interval because you put a bracket there, okay? But we have a less than or equal, okay? So remember when we're moving around and representing the result, remember to not omit any of the components of the inequality, okay? Well done. Questions with this one? Okay, well done.
Teacher,
Yes, go ahead. Turo, yes, please.
yes. I don't really understand when do we use brackets.
Oh, okay. Good question. Let's reinforce that, Arturo. So it's really very simple to kind of remember, Arturo. So let's look at the results. Okay, this is the final inequality that we're getting, right? And let's look at the results. Notice here, Arturo, that we have a less than, right? And over here we have a less than or equal. What is the difference when the inequality has the equal and it doesn't have the equal? When it has the equal, it means we are including as a part of the solution the number that is part of that the inequality is referencing. That means that there, the number 3 is part of the solution. It's included, right? On the other hand, the -2, that is not included as a part of the solution. Anything that's greater than -2, so -2, -1.9 is valid, but the -2 is not. Is that part clear, Arturo?
Yes.
Okay, so when do we use brackets and when do we use parentheses? It's very simple. We're going to use parentheses when the value is not included. We're going to use brackets when the value is included. Okay, you see that? So if it's less than, greater than, the value is not going to be included. It's going to be a parenthesis. If it's less than or equal, greater than or equal, if the equal is there, we need to include the value. That's where we're going to use the brackets. Okay, is that clear?
Yes, thank you.
Perfect. Okay. Any additional questions before we jump over to the next one? No? Okay, good job. Good job, you guys. Good job, you guys. Let's see. Let's go with problem number 30, please. Problem number 30. Who's got problem number 30? I forgot to specifically mention, but right now we're doing presentations, so you may leave your cameras on or off as you wish. But if you participate, turn your camera on. If I call upon you, turn your camera on, okay? So I think this one is from House Deathly Science. Is that correct?
Yes.
Okay, perfect. Let's see what we've got there.
Okay, so I wrote the expression, then we put the -4 to eliminate the +4 that is with the x, and we do it -4 plus 3, and 10 -4, and we got -1 is there is less how sorry
Less than, correct?
less than x, and 6 is greater equal than 6 to x, and that's it. We don't have to flip any signs because we don't divide we to a negative number.
Mhm. Perfect, perfect. This is, I'm glad both teams solved it differently. In the case of you guys decided, and this is correct, well done. You guys decided not to separate the inequality, right? So in the previous example, the inequality that had 3 parts, what House Algebra decided to do was to separate it in 2, solve it, and bring it back together. That's the correct procedure. You guys didn't do that. You guys worked with the same inequality, okay? Adding and subtracting or moving things around as you needed to. That is also a valid way of doing it. Both procedures are correct. And if we applied any of these procedures to the other problem, we should get the same result. Now, as you mentioned, what we do here, you subtracted -4 here. And for the inequality to, according to the properties and the theorems of the inequalities, if we do that, we need to do that everywhere. So we do the same over here, and we do the same over here. Then we just do the mathematical operations. This is going to give us -1. This is going to give us a 6. It's correct. We didn't have to flip any signs because we're not multiplying or dividing by a negative number, so things stay the same. And going back to Arturo's question, just to reinforce, the interval is going to be from -1 to 6. However, because the 6 is less than or equal, we're going to include the equal. I'm sorry, we're going to include the 6, and that's why we're using brackets. Over here, since the -1 is greater than, then there is no equal, and we use the parentheses. Okay? Good job, well done. And you also represented this in the number line, I think. Well, you put the values in the number line. Just a thing here, when we're representing it in the number line, if you're gonna be doing it, what you do is that you put the values, but what we do is that we're gonna put a parenthesis here, we're gonna put a bracket here, and then we're just gonna hash the interval so we can interpret the interval visually. In the previous example, in the previous problem, what were the intervals? House Algebra in the previous problem? -2 and 3, or no?
-2, 3.
-2, 3. So in that one, you had a -2, 3. And so in the previous one, the interval would have been marked in the number line as such. I believe it was an open interval, close, and then we just hash it here. I'm just doing this because remember that the solutions can be represented 3 ways. We mentioned that. This is way number 1, which is the inequality. Over here, this is way number 2, which is the interval. And over here, this is way number 3, that is the number line. Now, why am I mentioning this? Just be careful. There might be a problem that says that you have to do the 3 representations, and if you don't do one, it might not be considered complete. Okay, good job, you guys. Questions with this one? Yeah, these first examples, these are non-linear inequalities. I'm sorry, they're linear inequalities. These are the simple ones. Basically, the only thing we have to be careful there is the sign change. They're relatively simple, and we just have to be careful with the algebra. Okay, good job. Good job, Deathly Science. It's a cool name, by the way. I like it. Let's see problem 32, please. Problem 32. Problem 32.
It's me, teacher. I'm trying to change screen.
No worries, go ahead, please.
Okay.
Getting tired of humming. There we go. Perfect. Okay, let's see.
Let me present. Right. It's getting kind of slow. Let me.
Okay, just go to the second slide where you have the solution. There we go.
Here's the problem. Is the problem number 32? The problem said it was 100 plus x less equal than 41 minus 6x less equal than 101 plus x. The first step was to subtract 41 in each side, so we can eliminate the 41 from the middle. And as a result, it resulted in 59 plus x less equal than minus 6 less equal than 80 plus x. Then the next step was we subtract x from each side also. It resulted in 59 less equal than minus 7x less equal than 80. Then we divided everything between minus 7, so we can eliminate the negative number and to change the equal as well. It resulted in minus 59 divided by 7, and in the middle less equal than x less equal than minus 80 divided by 7. Is the notes, and at the bottom it says that we divided all the terms by minus 7. Being this a division and a negative number, as a consequence, the inequality changes from smaller than to greater than equal than. And here you can look that when we divided everything, all the terms minus 7, it was less equal than, but after the division, it changed to greater equal than. Here is more clear if you want to look at it.
No, if you could please leave it as you had it with both of the procedures on the screen, please. Well done. Well done. This is, I just want to make a small note here, just for everybody and for Luis. Well, first off, I have to ask a question, Luis, to you before I talk about the problem. Luis, I'm seeing a PowerPoint presentation that seems to be just yours. Is this included in what your house?
It's just that we trade as a PDF and I think it doesn't have the animation. So
Oh, okay, but this is part of what was sent to me, right?
yes, it's on the
Perfect.
presentation and as well because like it will be kind of hard if always the same person is sharing and sharing and sharing.
That's perfect. That's perfect. Thank you for clearing that up. Now, before I get into the solution, the problem is correctly resolved. I want to comment a couple of things for everybody. Pay attention, and this is being recorded. First off, me particularly, this is the way I like to see the solution to a problem. I don't mean by computer. That was well done. But I like to see the procedure and the steps. This is important. This is, by the way, you guys are studying to be engineers. This is important in engineering. This isn't important just for math. It is very important for us to, as engineers, to be able to break down the steps in the solution of a problem. It's hugely important as engineers. So I'd just like to give a recognition here to you, Luis, in your house. This is a great way to present the problem. I like that you did it in the computer and you also showed me your notes. This is great. I really like the way this looks. I'm not saying that the previous ones weren't well done. The previous ones were well done, but particularly I'd like to note that this way of presenting it was really well done. I want to note another thing. Luis, you sent me this screenshot yesterday, right?
Yes, to make sure if it was correct, the procedure.
At what time did you send it to me? Do you remember? Mr. What's up?
Let me check it.
I've got it here. Help me out there, check.
I sent it to you yesterday at 7:50 p.m.
7:50 p.m. At what time did I answer you?
7:55.
So that was a 5-minute lead time. For roughly. I'm mentioning this because I welcome you to do what Luis did. And a few others of you, Leo also sent me an image last week asking, and he sent it around 11 p.m. And how long did it take me to answer you, Leo?
Let me check.
Check the details, but I encourage you to do that. Okay, so Luis did the solution and he's like, just send me a screenshot. You actually sent me this screenshot, right? I don't think
Yes,
it
it
was.
was the same, the picture.
Yeah, but you sent me that and you said, could you check if it's okay? And I checked the procedure. I said, yeah, it's okay. If there would have been something to correct or note, I would have responded. But I encourage you guys to do that. I'm going to do my best to respond and answer any doubts you have. I'm mentioning this because there are problems that you guys had to do today, and there's a homework task for next Monday. So let's try to take advantage of that. But if the homework task is to be delivered on Monday before midnight, and I start getting a bunch of texts at Monday at 11 p.m., you guys are going to get a sermon. Okay, because it's not the hour that's the problem. It's not the hour. I don't have a problem receiving texts late. The problem is that if the homework task was tasked more than a week ago, then you should guys start doing it and not doing it on Monday, which is what I don't expect. But do that. Send me messages. I'll provide feedback. There's going to be some situations, depending on the types of problems, where if the problem is correct, like in the case of Luis, I'm going to say, yes, it's correct. If the problem is incorrect, I'm probably going to say, no, it's not correct. But here's a tip of where it's incorrect for you guys to solve it. I'm not going to completely solve it for you because that wouldn't be the purpose. Okay, so how long did it take for me to answer you, Leo?
I sent it a message at 10:06 and you respond at 10:08.
Okay, was I angry at you for sending me a message at 10:06?
No,
Did I seem angry?
no.
Wasn't really, believe me. Did I seem angry, because you sent me a message after 6 PM, Luis?
No,
I am not going to be angry. I'm gonna be angry if any of you send me messages. You're gonna get a sermon if you send me messages at 11:30 PM on the day that the homework is due by midnight, because but no, you can still ask me questions. There's just one little detail in this solution that I'm gonna note, and this is not a deal breaker, okay? Luis and your house. This isn't a deal breaker. I'm just putting it there because I'm a little bit OCD about certain things, certain math things. I'm OCD, and so I'm just gonna write it down just to note it, and then we're gonna go to break, okay? I'm gonna ask you a question, Luis.
Yes,
You've got 59, minus 59 divided by 7. And you've got minus 80 divided by 7.
yes, teacher.
Which of those two numbers is larger?
Minus 59.
Minus 59 divided by 7? So let's do the calculation. Minus 59 divided by 7 is 8 point, and we'll go to break after this.
I already did that, teacher, but because I wanted to put the numbers in order like you did before, but I was not very sure how it's done, so I did not do it.
Yeah, and again, it's not, this solution is correct. So if this were in the exam, you would have the point. What I'm just mentioning here is just sort of like, if you were to be maybe showing this to a mathematician, they might go bonkers just because of being OCD. So this is 8 minus 8.42, just to know. And this number over here is 80 divided by 7 is 11 minus
11.42.
11.42. So it's correct. Minus 8.42 is larger. Remember that we're negative. Okay, so we're on the other side of the number line. So that means that if we really want to be really OCD, we should try to put things from lesser to greater. Okay, so we would say minus 80 divided by 7 is less than or equal than x, less than or equal than minus 59 times 7. Again, the solution you guys presented is correct. I'm just writing that down again because I'm a little bit OCD, where I like to see the inequalities going from left to right. Okay, but the way the solution is presented is correct. I'm just noting that. Okay, well done. I really like the way you guys presented the procedure. Questions with this one before we take a break and start with some of the more complex problems for the second hour. Questions with this one? Nope. Okay, we're going to take a 10-minute break. It's going to be 10 minutes because I took 5 minutes away from you, and I'll let you know when we come back. I'm going to pause the recording. Okay, we're back. So let's go with problem number 34, please. Let's house, there we go.
Okay, in this problem, we just do we put 4x plus 2 in the middle. The minus 3 that was dividing, we multiply, the negative 3 by 2 and by 10 in both sides. Then we just move the number 2. So it was minus 6 minus 2 equal to minus 8. Then to left the 4x in the middle, and again the minus 2 in the other side, so it's minus 32. On the step 2, we just divide everything to remove the 4x to leave the x alone, and at the end we got x was less or equal than 2 and x was equal or greater than 8. So the final answer was -8 and -2.
Sorry about that. I lost my unmute. Perfect. Well done. Well done. Let me comment a couple of things here. Well done. Okay, the first is that when you guys multiply by the -3, the sign flips. And remember that that's an important part of what we need to remember. Okay, so yeah, you've got the original inequality here, and you are multiplying by -3 on each side to remove this. So you're multiplying by -3. And that multiplication is going to affect these two signs. And so what we're seeing here is that when you guys bring it over here, the signs are flipped. It's important, you guys. Well done. You have to remember that. The rest is just solving the inequality. And again, and the result is -8 to -2. Again, just being a little OCD here with the inequality. Just to go from less to greater. So this would be -8 less than or equal to x less than or equal to -2. And that gives us the interval. The interval is with brackets because we're including the -8 and the -2. And over here, when we're going to represent it in the number line, we're going to put the brackets. Oops. We're going to put the brackets and we're going to hash this part here. Okay, that would be the interval. Okay, good job. Well done. Questions with this one? I think the first half of the problems, roughly about first half, or maybe a little bit more than a third of the problems in the homework tasks, the first problems are problems of this type. Okay, good job, you guys. Questions with this one before we go to the next one? Nope. Okay. Now let's go, please, with problem. We're going to jump over to the nonlinear inequalities. And let's go with problem number 60. No, let me go in order. Wait, not 60. Problem number 54, please. Problem number 54. Problem 54. Who's got that one? Perfect. There we go. Let me give me a moment here to minimize my screen so I can see everything. Let me move this here. Okay. Well, before you guys begin, I'm noticing the note in orange, and that's fine. That's not a problem. If you guys maybe got stuck on a problem, this is the moment to unstick ourselves. Okay. So let's see what you guys try to do here.
Okay, so, well, the first thing that we had to do was get rid of the parentheses. And we did that by using this expression here. And the result was 1 and minus square x over x equals 0. And then to get rid of the x in the denominator, we multiplied the 0 by x. And we were left with 1 minus square x equals 0. And then we subtract the 1 on both sides, and we're left with the negative x square x equals -1. We divide, and the result would be square x equals 1. We get the root of that, and the x is equal to 1 and the other one -1. And then we got confused when filling out the chart.
Okay, Anna, thank you. Let me just make a few comments and questions also. The first common question is, when we have the inequality, first off, you guys agree that this is a non-linear inequality, right? It's a non-linear inequality, right?
Yeah.
And in the non-linear inequality, let's remember the steps. Let's remember the steps. And I'm giving you guys the steps for a reason. If we follow the steps, we should be able to solve the problem. What was step 0? Anybody, it could be you, Anna, or anybody in your house. What was step 0?
To equal to 0.
Correct. So step 0, would you agree, Anna, that step 0 is already done?
Yes.
We don't have to do it. So I'm gonna actually write these down here. These problems are might be a little bit trickier than the other. So step 0, we've already done it. Okay, step 0, we've already done it. This representation here, the way we have it, is step 0. Perfect. What was step 1? What did we have to do in step 1? Look at
Find the roots.
Find the roots. Right? Remember that, Anna? And the rest of your house? Step 1 was finding the roots. The roots are going to be the values that make the inequality 0. Okay? So I'm moving around my screen here so it doesn't block me while I'm writing. Okay? Are the values that make the mathematical expression 0. Are we okay up to this point, Anna, and the rest of your house? Yes? Okay. To find the roots, to do step 1, we need the mathematical expression to be factored. Factor means that if I have a polynomial, instead of having the polynomial, I need each of the factors that create that polynomial. Are we okay up to this point? So I'm going to ask a question. Is this expression, the way it's being given to me, is this expression, do we already have the factors here? Yes or no?
Well, yes.
Okay, correct, Anna. We already have the factors. So I just want to do this to put the message across, not for anything else. We don't need to do any of this. We don't need to do any of this. We already have the factors. What are the factors in the expression? We've got 3 factors. Can you help me identify those, Anna? What are the 3 factors that we have there? And factors are things that are multiplying each other, and we've got 3 of them, multiplying or dividing by themselves. What are the factors in that expression, Anna?
I think it's 1. And
1 isn't the factor. The factor is a mathematical expression.
1 plus x.
Perfect. Let's write them down here. I've got the eraser. Let's write them down here. We're doing good. So 1 is 1 plus x, correct? Anna, what is another factor that we have?
1 minus x.
Perfect. 1 minus x. And what's another factor that we also have?
The
Lonely by itself there on the bottom.
the x that's dividing.
Yes. The x, that's a factor as well. From each of these, we're going to get a root. What would be the root in this case? It would be x equals -1. What would be the root in this case? Anna, what would be the root in that case?
1.
1,
Oh
correct.
my- Yes.
1, correct. And what would be the root here? And to answer the question, Anna and the rest of you, when I ask about a root, what is the value that makes that factor 0?
Well, negative x.
Nope. What makes x 0? What value of x
0.
makes x 0?
Zero.
0. Right? So what do I substitute in the x to make it 0? It's 0. What do I substitute in the 1 minus x to make it 0? 1, as you said. What do I substitute in the 1 plus x to make it 0? Minus 1. And so the factor here is x equals 0. Those are the 3 things we need. Now, I want us to be very careful here, because this procedure that you guys did over here was a bit unnecessary. So when we already have the factors, we don't multiply that to get the polynomial, and then from the polynomial, go back and try to get the factors. We're doing a lot of extra work that we don't need to do. And by the way, we might get to the solution randomly, which is very dangerous because random means that we might get it correct and we might not. Okay, so are we okay up to this point, Anna, and the rest of your house?
Yes.
Okay, perfect. Now, what I did notice you guys did, you started filling out the sign chart correctly. Yeah, somehow you did get to the factors because, wait, before we do that, what was, Anna, do you remember what was step 3?
Well,
I'm sorry, step 2. I'm sorry, I jumped one. Do you remember what was step 2?
not really. Well, isn't it filling out the chart?
No, that's step 3. Before we fill out the chart, we need something that you already put here in the chart. Does somebody remember what step 2 was?
Oh, the factors.
No, the intervals. This is step 2. These intervals that we need to identify. Okay, that's step 2. What are going to be these intervals? We're going to establish them based on the roots. So we're going to go from minus infinite to minus 1, minus 1, minus 1 to 0, 0, 0 to 1, 1, and 1 to infinite. These are the intervals. This is step 2. Okay? Are we okay up to this point?
Yes.
Perfect. Now, what was step 3? You just mentioned it, and
Oh,
what was step 3?
filling out the chart.
Pulling up the chart, correct. And I believe you guys did that correctly. Filling out the chart means just evaluating the values of the intervals according to the factor. Okay, and let's review this, but I believe you guys did that correctly. So in the first case, correct, we've got the x. And so it's going to be minus 0 plus. That's correct. Then with the 1 minus x, we've got, if we substitute from minus infinite to 1, we're going to get a minus. This is a 0. From minus 1 to 0, let's see what we've got here. If I grab any number from minus 1 to 0, let's say that I grab minus 0.5 and I substitute it here, I'm going to get a positive number, not a negative number. This is positive. For 0, it's positive. For this, it's positive, positive, and positive. Remember that we're usually going to see a shift when we have the zero. We're usually not going to see changes when the zero is a reference. Here, if I substitute anything that is below the 1, I am going to get a positive. This is correct. A positive. This is correct. This is a positive. Again, if I substitute anything between -1 and 0, I'm going to get a positive number. For example, if I take 0.5, 1 minus 0.5 is 0.5. It's positive. This is positive. This is positive. This is 0. And this is negative. Okay. Are we okay up to that point, Anna, and the rest of your house?
Yes.
Perfect. Now, step 4, and I think this is where you guys got stuck. Step 4 is evaluating the expressions. And you're missing an expression here, you guys. Here, we're going to put the combination of all of the factors, which is the original inequality. 1 plus x, 1 minus x divided by x. Okay? And now we're going to evaluate the inequality. You're going to help me out here. Anna. Look at the expression here that's in yellow. One factor is multiplying the other factor, and then it's divided by the other factor. You see that?
Yes.
So, minus times plus is what sign?
Minus.
Divided by minus?
Positive.
Positive. Correct. Well done. We can actually go a little bit quicker with the rest because it doesn't matter if it's dividing or multiplying. The effect is going to be the same. So minus times 0 times plus, what are we going to put here, Anna?
And the second one,
Uh-huh.
well, it's 0 because
It's correct. By the way, anytime we have a 0, that's going to be a 0. Okay? So we can just write those down there. Here in this one, in the third one, Anna, minus times plus, what am I going to get?
negative. And
Plus times plus, which is the next one here,
positive.
positive. And plus times negative,
It's negative.
negative. So are we okay up to this point?
Yes.
Perfect. Now we're going to evaluate. Anna, the original inequality that we're talking about, the original one that was a part of the problem, what does it say? Is it positive or is it negative, or what are we evaluating in the inequality in the original one?
It's negative.
It's negative, correct, Anna, because it says less than or equal to 0. So we're looking for negatives and zeros. Okay, so the first column, Anna, does the first column comply with the inequality? Does that range comply with what we're looking for? Yes or no?
No.
Nope, correct, because it's positive and we're looking for the negative. So nope, this one does not. And any other one that's positive does not as well. And now in the second column, we've got a 0, Anna. Is that going to be part of our solution? Yes or no?
Yes.
Yes, because it's less than or equal. And remember that if we have the equal, we include the 0. So this is a yes. Is this one going to be included, the next one?
No.
No? This one here? What are we seeing here? Is it positive or negative?
The third one.
The third one, right here.
Oh, okay. Yes.
We're looking for, because it says that it's less than or equal to 0, we're looking for the negative ones. Anything that's negative is going to be a part of the solution, right? So this one is. Next up, we've got a 0. Is the 0 going to be included? Yes or no?
Yes.
Then we've got a plus. The plus is not included. We already said. Then we've got a 0. Is the 0 included?
Yes.
And then lastly, we've got a negative. Is this one included?
Yes.
Yes. So was this part clear, Anna, how we filled in that part?
Yes, because we had some signs that were wrong, so that's why we couldn't get the answer.
Okay. And remember, this is being recorded, and I'm going to update these slides so the complete solution is there in Blackboard as well. And that's why I'm going slow with the procedure so you guys can have it and it's going to be in the recording. And so the solution, in the end, the solution is going to be all of the intervals that are marked in green. So it's going to be from -1 to 0. And we're including both the -1 and the 0. And from 1 to infinite. This would be the solution. Now, again, you guys, there's a reason I'm giving you the steps, okay? So you can follow the steps and that'll help you out. And you don't have to do the problem putting the steps like I put it here. But if you try to follow the steps, then you shouldn't go wrong. I understand that maybe the part of the sign chart is confusing, but I know you'll get there with a little practice. Let me quickly just take a screenshot here. So I can keep this and update. Okay, and I'm going to send that screenshot right now in the chat. So you guys can have it. And there we go. Okay. Now, any additional questions with this one? Was it clearer, Anna?
Yes. Thank you.
Perfect. Any questions before we jump over to the next one? And again, when we're doing the workshops, this is valid. That's where we're doing the workshop. Maybe you guys got stuck on a problem. We're going to see it here. Okay. Okay. Good. Let's try to do a few others then. Let's see. I'd like for us to do problem 58, please. Problem 58.
Okay, I'm going to be sharing my screen.
Okay, perfect.
Okay, I don't know how to use Canva, so I'm just going to present this. So in problem 58, here's the inequality, which is 4x plus 5 divided by x to the second power is it's more on an equal than 4 divided by x plus 5. So our first step was to remove the divisions. So then we have 4x plus 5 times x plus 5 is more unequal than 4 times x squared because we move each division to the other side of the inequality.
Okay,
then we
I'm sorry to interrupt you.
Yeah.
I'm gonna stop you right there. Okay. It's important, again, that's why we're reviewing the problems and for us to remember a few things, and that's why I'm going to be mentioning them. Okay. Remember, we're working with an inequality, not an equation. Okay. And remember, if we're working with an equation, we can move around and multiply and divide however we want. But if we're working with an inequality, we can't just send things which have variables multiplying or dividing to the other side. Do you or any of your housemates remember why we can't do that?
Well, if I remember correctly, it's because we can only like sum or subtract, but I don't remember exactly why we can't multiply and divide.
Okay, the answer to that, Andres, is, do you know when you have a variable, and the question even kind of answers itself. When you have a variable, do you know the value of that variable?
No.
No, because that's why it's a variable. So you've got an X. So that X at any given moment can be positive or negative. Would you agree?
Yeah.
So if I assume that the X is always positive, then the procedure you just did is totally valid. But if at any moment the X or any of the X's can be, or any of the factors, just to be clearer, not only the X, any of the factors could take on a negative value, then that's where we've got a problem, because multiplying or dividing by anything that's negative is going to automatically change or flip the inequality. So we have to be very careful with inequalities with doing that, to trying to solve it like an equation. Now, the solution you got, this is where we have to be careful. The solution you obtained might, in the end, be the solution of the inequality. But that might be a random case where all the intervals coincide and the solution we get this way is the solution to the correct inequality. In other cases, we might see that the solution that we get this way, by not considering the signs, is an incomplete solution that doesn't have all of the intervals considered, okay? So let's just be careful with that, okay? Okay, let me, you're gonna help me out, Andres, here. Let's do this. And again, I'm not saying that we might not get to exactly the same solution, because we randomly might. But let's do the complete procedure, taking all of the considerations into account. So let's do this. I'm going to share my screen here, and I'm going to share the whiteboard. So you're going to stop sharing, and you're going to help me out. Okay. I'm gonna just share the whiteboard. Okay. And again, you guys remember that the purpose of the purpose here of the workshops is to practice. And again, we're going to be recording them. The purpose of the workshop isn't to grade. Okay, so what I want in the workshops is for you guys to participate. So right now you're doing great, Andres. Right? Even if there was a little detail in the procedure, it's not like, oh, this is wrong and no. This is part of what the workshops are for. So help me out here. Andres, first of all, can you tell me or dictate to me the inequality again?
Yeah, it's 4x plus 5.
Whoops. Okay. Just orient myself here. 4x plus 5.
Divided by x squared.
Squared, perfect.
Is greater or equal than 4 divided by x plus 5.
Okay. Okay, so what we're going to do is, taking under account the premise that we shouldn't multiply or divide things with variables, but we can add or subtract. And the step 0 is to put everything with regards to 0. That would be step 0. What we're going to do is the following, and I'm going to ask for your help here. So you try to do in your notes what I'm going to be doing here. So what I'm going to do is the following. I'm going to say 4x plus 5 divided by x squared. And so this 4 divided by x plus 5, I'm going to send it to the other side subtracting. I can do that without affecting the inequality. So this is going to be 4 divided by x plus 5, right? And this is going to be larger than or equal to 0, right?
Yeah.
Help me out here, and let's try to do it together. You could what the next thing we need to do is that we need to have everything in one quotient with the factors. And so what we're going to be doing is that we're going to be using the common denominator. And the common denominator is going to be these two elements here. These two are going to be the common denominators. Okay. And we're going to join them into one fraction here, which is going to be, the common denominator is going to be x squared multiplied by x plus 5. And I'm going to do it here, Andres, and you just verify that I don't make a mistake, because I might make a algebraic mistake, so you verify it there. So if we're doing the common denominator, then that means that 4x plus 5 is going to multiply x plus 5. And the minus 4 is going to multiply x squared. Okay, that's what we should get, right? And now I'm just going to multiply some things here. And so this is going to be equal to 4x squared plus 5x plus 5 times 4x, which is 20. This should give us 25x plus 25 minus 4x squared. And the factors in the bottom, we leave those as they are. By the way, let's not make the mistake of multiplying the factors that we already have in the denominator. And this is going to be larger than or equal to 0. Okay. What we see here is that the 4x's, and again, check me here on this just to see if I don't make any mistake. And if I do, let me know, please. The 4x squared are going to be eliminated. And we're going to get to have 25. And I'm going to factor that. So it's going to be 25x plus 1 divided by x squared times x plus 5 larger than or equal to 0. Okay. Are we okay up to that point, Andres?
Yeah.
Okay. And now we're going to do step 1, which would be to find the factors. Find the roots. And could you identify what the roots are going to be that we're going to be working with here, Andres?
Well, the first one is going to be x minus 1.
Correct. That's out of the first factor, x minus 1.
I believe the second one is going to be x minus 5.
Correct. Perfect.
And the third one, x equals 0.
Correct. Perfect. Those are going to be the 3 roots we're going to be working with. And if you remember step 2, I'm sorry, we're going to establish the intervals. Step 2 is going to be to establish the intervals here. So help me out. How would the interval? Do you know how the intervals would be here, Andres?
Well, I'm analyzing it. I think that it's going to be minus infinite, then minus 5.
Correct. Yeah, we go from minus infinite and then just kind of drop off.
Yeah.
Or get to each of the numbers. So minus 5, correct? You consider the minus 5 is also included.
Yeah.
Then
minus 5 to minus 1.
Correct. And then we include the minus 1.
And then minus 1 to 0.
Minus 1 to 0. This is one of the lengthier ones that are going to have, I'm going to write those on the bottom. We're going to have also minus 1 to 0. We're going to include the 0.
0, yeah.
And then we've got, what's the last one?
0 to infinite.
Correct. Good job. Step 3 is going to be the sign chart. And for the sign chart, we're going to establish the intervals here. And we're going to do this here. We're going to go from -1 to 0. I'm sorry, from minus infinite
To -5.
-5, correct. And write these down as small as possible so they all fit. Then we've got -5, -5 to -1, -1, -1 to 0, 0, and 0 to infinite. Okay.
Yeah.
And and over here on this side, we're gonna have the factors, and the factors are gonna be x plus 1, x plus 5,
X square.
x squared, and the whole the whole thing, which is 25 times x plus 1 divided by x squared times x plus 5. Okay, and we're gonna fill this in, and I'm gonna ask you as well here, Andres, to help me fill this out.
Yeah.
Let me just
So
start doing that. My lines are gonna be really nasty here, but you guys understand. We're not. I was gonna say that when we were here in the classroom, I'm gonna ask you guys to write in the tablet, but we can't do that because of the social distancing. But the perspective is kind of interesting when it's not completely aligned with what you're looking at, but we'll get there. Let me do just this one here, last one, and help me out here with the sign chart, Andres. And a tip here with the sign chart is as follows: anything that has a 0 in it, any of the roots are going to generate a 0 automatically for the corresponding factor. So the x plus 1, there's going to be a 0 here. In the x plus 5, there's going to be a 0 here. In the x squared, there's going to be a 0 here. And that's it. By the way, it's 12:50 already. So technically the class has ended. I'm just going to complete the problem so it's recorded. If you guys need to leave for your next class, that is fine. It's not a problem. You may leave if you wish. We should take maybe 3 more minutes to finish this up. And you as well, Andres. If you need to leave, it's not a problem. So here, what we're going to have is if we have anything that's larger than, anything that's less than -1, all of this is going to be negative. Would you agree, Andres? And all of this is going to be positive. Over here, anything that's less than the -5 is going to be negative, and anything that's larger is going to be positive. In the x squared, what are we going to see here in the x squared, Andres?
they're all going to be positive.
Correct, they're all going to be positive because it's an x squared. And we're almost done. Now what we have to do, help me out very quickly here, Andres. Minus times minus times plus, what do we get here?
Plus.
Plus. Whenever we've got a 0, we get a 0. Minus times plus times plus.
Minus.
Plus times plus times plus.
Plus.
And the same occurs over here. And so lastly, we're just going to evaluate. That was step 4. In the inequality that we're working with here, which is this one, it's larger than or greater than 0, Andres. Would you agree?
Yes.
that means that we're looking for positive and 0. Okay, so does the first range comply? Yes or no?
Yes.
Does the 0 comply? Yes or no?
Yes.
Yes. Does the negative comply? Yes.
No.
Nope. Does the 0 comply? Yes or no?
Yes.
Yes. Oops. And we've got a plus here. This complies as well. The 0 complies as well. And the plus complies as well. So this means that our solution would be the ranges that include that. So it would be from minus infinite to -5. And this would be including the -5. Union from -1 to infinite. Okay, this would be the solution. And this last thing that we did over here is step 4. Now, we might have gotten the same solution using the other procedure. But technically, mathematically, the procedure of sending things multiplying to the other side, it would be incorrect. Okay. Questions with this one? Was it relatively clear, the procedure? Questions before we leave? No? Okay, I'm going to upload this to Blackboard later today. And I am going to upload the class recording as well. I'm just going to send this here in the chat. And before we go, just one thing very quickly. I'm gonna send it in the WhatsApp group. But I've moved the homework task delivery for Tuesday, not Monday. It's going to be on Tuesday. We're going to do deliveries of homework tests on Tuesdays or Thursdays, so we have the opportunity in the morning to answer any questions. So not Monday, Tuesday. Okay, you still got one more day to do it. And if you guys have any questions, let me know. I'll upload these to Blackboard as well as the corrections to your problems. I'll see you guys, some of you next week, hopefully. Take your precautions time-wise coming to the campus because of the entry and all that. And if you have any questions, let me know via WhatsApp. See you guys. Have a great weekend.
Bye, teacher.
Thanks, teacher.
Thank
Bye,
you,
teacher.
teacher.
Thank you. Have a nice
Thank
weekend.
you.
Bye.
See you next week.
See you.